What's going on, guys? Welcome back to another tutorial. Today we are having a look at a very nice outline shader. So as you probably saw already, we have this nice little black line just surrounding all the edges of any polygon that uses the shader. So this gives us a more cartoony feeling to the whole game, and it pairs super good with cell shading. Just before we get started, I'd like to just say something really quick, some quick notes. Because there's multiple ways to go about doing this kind of effect, and one of them is to pull out your normal. So just take, say, the normal of that square and just pull them out, and if you were to pull them out, you end up with a face in front of it. But that's actually not the way we're actually going to do it today. So somebody on Discord found a better way. This somebody is Glasto Studio, and I'd like to thank him for making that shader. Basically, he's the one giving us a shader today. The technique we're going to use is quite cool actually, and I'm quite bad at explaining it, so I'll just show you visually what it does. Basically, we have almost another mesh spawning inside of this one, but that's not really what's happening. But as you can tell, we draw the same exact object but a little bit bigger, and then we make sure that we always see our texture in front. So like the real object is always in front. So that's actually quite cool, a really nice way to go about it. And if you actually go ahead and put that on the cube, we should actually not see any problem. So I'll just drag and drop this thing. And as you can tell, we don't see the problem you would actually run into if you were to extrude the normals. Alright, so without further ado, let's just get right into it. And I'll just go ahead and get rid of everything like I always do at every beginning. I'm going to get rid of outline and the simple deformation. Actually, no, the smooth outline. And as always, we're going to right click, create a new shader. This shader is going to be a unlit shader. This is going to be for outline. Let's do the same exact thing for material, so outline as well. And I'll just put that back on my player. We're then going to open up the outline shader in Visual Studio and start coding this thing. Alright, so first line right here, N3K outline. Well, actually, this was done by GTS at first, but since we want to keep everything in the same folder, I'll just put it in 3K. But thanks again, man, for making the shader. Really appreciate that. Alright, so for the properties, we're going to need a outline color. So outline color just like this. And we're also going to need a outline, I could say size, width. Width is better. Let's put it width. So for this one, that's going to be the outline color, of course. It's going to be type of color. And by default, we'll give it a 0001, which is basically just a black color with alpha. Now this one is the outline width, so same thing, outline width. It's a range, so basically it's a float in between. We could be putting something like 1 and 5. Make sure you put your dots. And a default of, say, 1. Or maybe 1.01. So it has like a really small outline. The outline actually starts at 1. And that's actually all we need. Alright, so now for the sub shader, we are going to take a whole different approach. We're going to go a whole different way from what we used to do in the past. And this might be like only a one-timer, but we're going to explore another way of doing this. You can actually declare your CG code outside of a pass. So what we used to do before is something like this. So you would go like pragma, say vertex vert, and you would do it inside of a pass. So it looks something like this. And then you would go ahead and just do your whole pass. Now, you don't really have to do it here. What you could do instead is you can do it on this level right there. So you can do it on the sub shader level as well. But you can also do it in between the properties and the sub shader. And that's what we'll try today. So we'll try to actually declare some of our CG code at the top here, so everything beneath it, reuse it in the future. So we're going to have a look right here. We're going to start with a CG include code. Like this. This is required, of course, when you do CG. And then you do include unity cg.cginc. This is actually something they give you by default, but I removed it earlier when I just delete everything inside of the sub shader. Okay, so now when we're done with that, well, first I'd like to close this off by doing an end CG. But in between these, we're going to go ahead and start declaring our structures. So we're going to start with the app data. And inside of the app data, I'll keep two things. So I'll keep a float4 for the vertex with the semantic position. So automatically it's going to give me the position of the vertex, and a float3 normal. So I get the normal of that vertex. Alright, so we have the app data done. Now let's go for the v2f. So struct v2f. And I'm a little bit tired of the autocomplete on this thing, but we're gonna get through it. Float4 position. Semantic is position, of course. Float4 color. Semantic is color. And float3 normal. Semantic is normal. Standard stuff. And then right inside of here, right inside of the CG code, we are going to declare the two parameter we are going to be using up there. So the two properties we declared. So one of them is a float, so float outline width, and the other one is a float4 outline color, just like this. And this is basically, you probably realize already, but this is the exact same flow you would have inside of a pass before, but we're doing everything right in here before even going through the sub shader. So we declare pretty much everything we need, but we're going to go one step further in that. We're going to declare a vertex shader right here. So a v2f vert, just like we would do in a pass, same exact thing as we would do in the past, but we do it somewhere completely lost right here. But this way we can actually use it in multiple passes if we want to in the future. So v2f vert, we take in the app data v, so v contains a vertex position and also a vertex normal. And what we're going to be doing with this one is we're going to say v.vertex x, y, and z is going to be times equal to the outline. Now basically what we're doing is we're taking every single pixel and just expanding it on the actual normal. So now if I were to try and explain to you what this does exactly, it's just imagine we take a point, any point, so say right here. What it does is that it multiplies it, well, the position of this thing in the 3D world, and multiplies it by the normal. Now the normal is, you know, if we're on that face, the normal is something that is perpendicular to the center, so something like this, and it would go in that direction. The reason it's actually like that, well, I'll just try to explain the normal as well. Normal is something that is always 90 degrees on the plane it is right now. So this quad right here, you see, it has to be 90 degrees like that and like that, and the one axis that is popping up, that's the normal. So what we're doing is we're taking this pixel and we're saying go this way, and we're doing that for every single pixel, so everything gets bigger basically. I hope this was not too weird of an explanation, but we're gonna move on. Right after that, we're going to start declaring our v2f_o for the return parameter. We're going to say o.position is equal to unity object to clip position v.vertex. So we're transforming this back to a world space. Then we're going to set the color of that vertex to outline color. Finally, we're done. We're going to return o. Right, so now this is where I could actually go ahead and declare the pixel shader, but it's going to be different for the outline and also for rendering the object normally. So I won't do it in here, but we're pretty much done declaring everything that is CG inside of the shader right here. So let's head into the sub shader now. And inside of the sub shader, we'll need two different paths. The first pass is going to be for rendering the outline, so we'll just type that right here. And the second pass is going to be for rendering the object on top of it, so like a typical normal render. The first call we're going to have in the first pass is actually to set the Z write to off. This way we don't write it to the depth buffer, and other things can be rendered on top of it. Now, once we're done with this, we declare a CG program and then we do it and CG. Now realize that this one is a CG program and not a CG include. Really important you realize that. And we're going to say, well, which fragment are you going to be using? You're going to be using pragma. Let's start with the vertex first. So vertex vert, which is the one we declared up there. And then for the fragment shader, pragma fragment frag. Now notice we don't have a fragment shader anywhere, so we're gonna have to declare it in here like we used to do. And let's go right ahead. So have full frag v2f, and I'm just copying over from Glassdoor Studio shader right now. And all we do is we return the color. So return i.color, just like this. Now I just realized something that we might actually want to swap over. So basically what he does right here is that he takes in the vertex we have in parameter and then he applies the color. But I think what I'll be doing instead is we'll just, because basically the color of that vertex is simply, oh, the color, outline color, so it's the same exact thing. So what if we get rid of it right here? We get rid of it in the v2f, but we actually use it down there. We might have to declare this thing here as well, but we'll find out a little bit later on. Right now I'll be sticking with this. So that's all we need to do for the outline. All we have to do really is just to render at the proper place, the proper color basically. And over here we're rendering the the normal mesh but bigger. Now the normal pass, the normal render, we did it so many times. I invite you to just go over here, create a new unlit shader, and you just want to be copying this pass basically. So there's a lot of stuff in here. You can copy this over. Of course you're gonna have to change a few things, such as maybe redeclare your v2f, because this one takes in a CV. Actually it's the same thing, but it takes in the UV and you'll need it to actually apply the texture. There's gonna be a few things you're gonna have to change, but over here I'm actually going to copy over what Glassdoor Studio has done. He's actually using a a surface shader approach right here. So it's like a different way of typing in your shader, but in the end we get the same exact result. So I'll actually try and show you this thing as we do it, else you can just use a normal shader. So for this part, I'll just be copying over what I have on the other screen right here, and I'll show you exactly, well, I'll try to show you and explain what's going on. So this is some surface shader language, and it uses a color right here that I didn't declare at the top. Let's just head back to the top really quickly and declare ourselves a color in the properties. So of course this is not needed if you're not going to be using this kind of technique, but I'd like to actually go through it and show it to you while we're at it. So what color is this thing? Let's go check real quick. And we have a few compilation problem. So let's go ahead and double click here. I need to have some semicolon at the end of the structure. So that's cool, that's fine. Let's see, do we have any more errors in here? Outline. Outline is not defined. We want to be using outline width instead. And does it compile now? It does compile. Okay. So it's actually compiling right now. This is why my screen is glitched. And here we go, we're back. So now, as you can tell, we get this very, very slight color right here. And that's because, do we have full alpha? Yes, we do have full alpha. We have a little bit of problem with the ocean because of the Z writing order. But we're almost there, as you can tell. Let's go have a look at what exactly is going on down here. So we start with the Z write on, so we make sure that this normal render actually writes to the Z buffer. That's fine. Now, right here we say material diffuse color. Color is the main color that you see over here. So this is going to affect the object as normal, just like a normal standard shader. Ambient is the same exact things. We say lighting is equal to on. Set texture, we set a texture that is our main texture. That's the one we actually have in properties as well, and it uses a constant color. This one I'm not quite sure what it does, and also this one I'm not quite sure what it does. I'll be super honest, I'm not really a professional at the standard way of writing shader, but if you'd like to have some more information, I invite you to look over to the Shader Lab syntax, because that's how it's called. So Shader Lab syntax and you can find code similar to this and have a little bit more explanation, but I really do prefer the old way of doing things with the CG code. So let me quickly have a look why we are not actually writing to the Z buffer properly. And the reason it does not work properly right now, it's because I'm a little bit stupid and I forgot one of the most important thing. So if you check down here, we have the render queue. This is from the shader. Right now it's default on 2000. 2000 means it is a solid object, which would be true if we didn't have the Z writing on off for the outline. So if we just bump this up to say geometry, that's 2000, alpha test, as you can tell, we get the 2450, and it writes on these objects, but the water in the back is actually a transparent object, so it's rendered after. So what we need to do is actually bump it higher than the water. Let's try this. So this is not working. Let's go a little bit beyond that. Transparent is 3000 and it's actually gonna go through. Now you don't actually have to put it down here every time. What you can do is simply go back in the code and put the sub shader. You go over here, you say Q is equal to transparent, which is basically Q is equal to 3000, as we just saw. If you want to make sure that if there's multiple objects on this transparent layer, you can say transparent plus 1, which is going to give you 3001. But we'll leave it like that right here. So this way, we should end up with a properly working shader. Very nice outline. We can play with the outline width. And as you can tell, even when it's behind something, it does not glitch. It's actually a pretty nice outline. And you can play with the color, so maybe like a red outline. You can play with the size, make this way too big. And that's about it, guys. I hope you enjoyed this video. Thank you so much to Glasto Studio for handing out this shader to us, a really very smooth outline. I was going to show you something that wasn't so smooth and wasn't so cool, but he actually found this technique before I released the video. So thank you so much again, and thanks for watching, guys. I will see you next time.